Numbers don't lie. Think it through. Break it down, prove it right. Let's solve it.
Hello guys, today we're going to focus on surds that include roots, but I'll show you how to counter such questions. Stick around and go with me throughout the whole video. Let's come on. You might be given a question that says 2 the square root of 3, then plus 9 the square root of 3 plus minus 16 the square root of 3 plus 6 the square root of 3. First thing first, the only thing that you have to do first, it is just to look at each term. Look at this term, look at this term, and this one, and this one. Find the thing that is similar in each term. So when you do observations, now you see that the only thing that is similar here among all these terms, it is the square root of 3. Now the only thing that you have to do is to factorize. When you factorize, you take out the thing that is common among all the terms, which is the square root of 3. The square root of 3 is here, the square root of 3 is here, the square root of 3 is here, and the square root of 3 is also here. Then, because you've taken out the square root of 3, the square root of 3 will be taken out also here. If you take out this square root of 3, then you're left with 2. And also here you remove the square root of 3, you're left with 9. Then here you remove the square root of 3, you get 16. Then also here remove the square root of 3, then you're left with 6. Then when you punch your calculator, punch this into a calculator, you get 1. Just like this. Then here, the square root of 3 times 1 is just the square root of 3. This is your answer. You see that this question needs you just to open your eyes. When you open your eyes, you'll see the answer in the front of your face. As we move on, you'll see that this kind of questions might be countered in multiple ways. But yeah, let's continue. Yes, sometimes you may be given a question like this. It is similar but not similar to the previous one. Why am I saying that? The previous one was having similar things in their terms throughout the whole apparatus. Oh, this is Roman figure 2. Here, you're gonna factorize, but your factorization should all be about grouping. Then when you group, then now you'll see that everything is okay. Then we'll say 2 the square root of 3. What's having the square root of 3 here? It is negative 16. By arranging, plus 9 the square root of 2 plus 6 the square root of 2. Now you see that everything has been arranged. Then now you group. You group plus, bear in mind that always here there's a positive sign. Even if here there was a negative, here there will be a positive and the negative will be here. But because this is positive, we just put positive here. 9 the square root of 2 plus 6 the square root of 2. Just like this. Because now you have grouped, you'll take out the thing that is similar on both sides. Does 16 get divided by 2? Yes, it is possible that 2 can divide 16. We are going to factorize by taking out 2. Is the square root of 3 on this side and also on this side? Yes, the square root of 3 is also present. Then now, this will cancel this, then I left with 1 minus 16 divided by 2, that's 8. The square root of 3 will cancel the square root of 3, then we left with just this. Then plus. What's similar? Which number is both on 9 and 6 that can divide 9 and 6? It's obviously 3. 3 can enter 9 and 3 can also enter 6. You're going to take out 3. Then here, when you look, what's similar on both sides? It's the square root of 2. 9 divided by 3 gives you 3. This cancels this, then I left with just that. Then 6 divided by 3, you get 2. Then the square root of 2 cancels the square root of 2, then I just left with this. Then now when you do it, you're left with 2 the square root of 3. Okay. Then this 1 minus 8, it gives you minus 7 plus 3 the square root of 2. This will give you 5. Then your final answer is, just know that this negative 7 won't multiply inside the root because it doesn't have a root itself. If it had a root, That's whereby it multiplies inside the root. Therefore, there is no root. That means it will multiply outside. So it's going to be negative 14 the square root of 3 plus, now 5 will multiply outside. So it's going to be 5 multiplied by 3, and that's 15 the square root of 2. Then now you conclude your answer. Your answer is 15 the square root of 2 minus 14 the square root of 3. And this is your answer, ladies and gentlemen, for this. Let's move on and see what the next question has for us. This is the third question. Like I said, the questions are going to be tougher and tougher. If you don't know the kind of questions, this kind of questions, you won't be able to answer anything in an examination. So that you pay attention to your teacher, or even if you don't want to listen to your teacher, you can find tutorials on YouTube like this one. First thing first, you should find the factors of 75. And while finding the factors of 75, look for a number that can give you a whole number when you place it inside a square root. Finding the factors of 75. You cannot divide 72 by 2. But when you divide it by 3, you get 25 times 3. And the factors of 18, it's going to be, you divide by 2, you get 9. You divide by 3, you get 3. You divide by 3, you get 1. Can 3 give you a whole number when you place it inside the square root? No, that means you have to multiply 3 and 3. Then 3 times 2. And this will give you 9 times 2. When you place a square root here, it will give you a whole number. That means here it's 9 times 2. Always, there should be a number that gives you a whole number when you place a square root. So if you can see, it's times and times. It's going to be the square root of 25 times the square root of 3 minus the square root of 9 times the square root of 2. Then the square root of 25 is 5 times the square root of 3 minus the square root of 9 is 3 times the square root of 2. Then now you compute your answer. Your answer is 5 the square root of 3 minus 3 the square root of 2. And this, ladies and gentlemen, is your final answer. Why cannot you continue with the answer? Because these are unlike terms. They are not the same. This one has the square root of 3 and that one has the square root of 2. So they are not, understand? Let's see what the next question has for us. Yes, this is the question. So sometimes you make it. Okay, let's do this. I'll make this very quick so that the video cannot be too long. So, fine. Sometimes you may be given a question like this that includes divisors and all those things. Like I said, you should find the factors. You know that 48 is 4 times 3. You know that 4 times 4 gives you 16, and 16, you can put 16 inside a square root. Therefore, it's going to be 16 times 3. That means it's the square root of 16 times 3 plus the square root of 27, which is 9 times 3, all divided by the square root of 25 times what? Times 3. The square root of 16 is what? 4. The square root of 3 plus the square root of 9 is what? Is 3. Then the square root of 3 divided by what? Why did we write 3 the square root of 3? We wrote 3 the square root of 3 because the square root of 9 is 3 and the square root of 3 doesn't give you a whole number, so you just write the square root of 3. Then the square root of 25 is 5, the square root of what? 3. Then now you see. So let's continue the question on the other side. So I'll just write it right here. It's 4 the square root of 3 plus 3 the square root of 3, all divided by 5 the square root of 3. When you see here, the square root of 3 is present here, it's also present here. Now you factorize. You take out the square root of 3 outside. Then it's going to be the square root of 3 outside. Then, because you've removed the square root of 3, you're left with 4 plus, then here also remove the square root of 3, then you're left with 3. All divided by 5 times the square root of 3. Why are we saying times? Because the only thing bonding 5 and the square root of 3 is multiplication. So therefore, the square root of 3 will cancel the square root of 3. Then you're left with 4 plus 3, all divided by 5. Then your final answer is 7 over 5. This is how you do the kind of a question. Let's see if we have any other questions that we might answer. No, seems like that's the end of our video for today. Hope you enjoyed it. Make sure you like, share and subscribe. And yeah, that's all. If there were errors, please point them out on the comments.
Number numbers don't lie. Think it through. Break it down, prove it right. Let's solve it.